Hello guys, this is Paul McWhorter with TopTechBoy.com, and we're here today with episode number 32 in our incredible new tutorial series where you're going to learn Fusion 360 or you're going to die trying. What I'm going to need you to do is pour yourself a nice tall glass of ice cold coffee. That would be straight up black coffee poured over ice, no sugar, no sweeteners, none needed. And as you're pouring your coffee, as always, I want to give a shout out to you guys who are helping me out over at Patreon. It is your support and your encouragement that keeps this great content coming. You guys that are not helping out yet, take a look down in the description. There is a link over to my Patreon account. Think about hopping on over there and hooking a brother up. But enough of this shameless self-promotion. Let's talk about what I am going to teach you today. And what I'm going to do is I'm going to show you my solution to the homework assignment, which I gave you in lesson number 30. And that homework is lesson number 31. And what that homework assignment was to model a PVC elbow unit using Fusion 360. How many of you were successful? If you were successful, leave a comment down below. I am legend. If you were not successful, leave a comment down below. I folded up like a cheap Walmart lawn chair. Or the third option would be I never even entered the arena. I just thought I would wait a week and watch you do it. Guys, it's so easy when you see me do it and then you think you understand it. But you just understand that I understand it. To really show you understand it, you got to do it before you watch me do it. So if you haven't done it yet, you hit the old pause on your thing and you go do it by yourself and then see, come back and see if I do it the same way or a different way. But I digress in way too much introductory banter. Let's jump in and let's look at what I actually wanted you to model so you can fire up your Fusion 360. And this is the elbow that I wanted you to model. And what I want you to see is it's got this little bit of an extension here that is more narrow than the overall body. And then that, if we printed two of them, would actually fit in here. So you can see the outside diameter is uniform all the way across, but then this segment is thinner on the, this segment is missing the outside portion and this segment is missing the inside portion, and therefore those two segments, if we printed two of them, would fit together. And then when you see this, all of a sudden you think that you could kind of come up with your own, sort of like something like a Lego set that's just a bunch of different tubes and connectors and T-joints and straight joints and just all types of different things. Because really, if you could do the elbow, you could do any of the things to create kind of a complicated set of piping, if you will. So I'm not going to start here. I'm going to start with a new design. So I will come over and I will say new design, and I will kill this design that I did last week, even though I really do. If you guys didn't see this lesson, make sure to go back and watch last week's lesson. I think that was cool. I do want to really print that. I do really want to print that, but we're going to kill it for now. We're going to come in here, and now the other part of the homework assignment, that elbow needs to be parameterized so that you can create any elbow that you want once you get the model in there, okay? So since it is parameterized, we are going to start by creating our parameters. Well, if I look at this, I'm going to need an overall outside diameter, and I am going to need an overall inside diameter. So the outside diameter and the inside diameter are the ones that are not associated with these thin regions on the end. It's just the total outside diameter and the total inside diameter. Okay, now what else do I have? Well, I have a wall thickness. I have a thickness of this thing. And then what else I have is I have some overlap region that however long this extension is, this little inset needs to be the same amount, so I'm going to call that overlap. And then I need to have some diameter or radius, I guess I should be saying, of this little extension piece, and then I need to have a radius of this piece. So you see, this radius is different than the overall inside radius. So I need the radius here I need the radius here, I need the radius here, I need the overall inside radius, I need the overlap, and I need the thickness. And then I think the one other thing I need is how sharp do I want this curve. So I need kind of like a radius of curvature for going around this corner. I hope that makes sense. So we're going to come over here now, and we're going to come under modify, and we are going to create our parameters. So what is the first parameter that I am going to want? The first parameter that I'm going to want is the outside radius. So we're just going to call that OR, and I'm going to set that to about 38 millimeters. Okay. And then I am going to have an inside radius, and I am going to set that to, no, I need to have a thickness. So I have the outside radius, and now I have a thickness. So after outside radius, I'm going to set the thickness to be 4 millimeters. All right. And so what that is going to be is that is going to be the wall thickness in this region that hasn't necked down on the outside and hasn't necked down on the inside, but it's that full wall thickness in this region that's going around the corner. I hope that makes sense. So we come back over here, and I lost my parameter table, so I'll call it back up here. Change parameters, there it is. So I've created outside radius, OR, thickness. Now I need IR, or inside radius. And again, that's in the full thick part. That's not in the part that's been trimmed down on the outside or trimmed down on the inside. Well, if I have defined the outside radius and I have defined the thickness, I can't just put in a number here, because I would be over constraining it. The inside radius is what? It is the outside radius minus the thickness, okay? Like that. Now what I'm going to need to do is, you wouldn't always want this to just be a simple corner. Maybe this would want to be extended out, or this would want to be extended out. Not the overlap, just you might want to come out with some segment of pipe that might be longer. You might want to go more than just going around the corner. And so for that, what I would do is get my parameter table back up here. Okay, so I'm going to call it a span height, and that's like how tall it is from the bottom up to the corner, span height. And I think that I will make that about 60 millimeters. Okay, and then I am also going to do a span L for span length, and then I will make that a 60 millimeters as well. Okay, that looks pretty good. Now what I need to do is I need to come in and I need to give it that curvature, and like, what is the radius of curvature? And I think I'm just going to make that like whatever the outside radius was, so it goes around the corner just as sharp as sort of like what it's like you would be wrapping it around the thing itself, if that makes sense. But I think that would work pretty well. Now what I need to do is I've got to come in and I need to think about the radiuses of this region and this region. And so let's start with the I'm going to have to think the inside lip. You see, this is the inside lip and this is the outside lip. The outside lip fits over the inside lip. The inside lip slips into the outside lip. And so we need to go in and we need to put some parameters in for that. So I'll come over here and I will say modify my parameters, and I'm going to add a new parameter, and that is going to be the OLR, the outside lip radius. And that would be the outside lip. What we're going to be putting in is the inner radius of the outside lip. Well, what would the inner radius of the outside lip be? The inner radius of the outside lip would be the outside radius, the overall outside radius, and then minus the thickness. No, it would be 0.5 times the thickness. Okay, so I'm coming in by 0.5. I'm coming in by 0.5 times the thickness. So what does that mean? Let me see, okay, here. Okay. What does that mean? That means that this thickness is going to be half of what the overall wall thickness is. And over here, this is going to be half of what the overall wall thickness is as well. And we'll do that in 2 different steps. So, okay, but now this is really, really important. And so here, if I came on the outside lip, if I came in by half the thickness, and then on the inside lip, if I made it half the thickness, that is leaving no tolerance at all. That would be kind of like a jam fit. So what I want to do is I want to leave a little bit of margin. And so instead of doing that, I want to go 0.95. And that is going to make that hole just a little bit bigger. It's going to make the hole a little bit bigger. Why? Because I'm subtracting a smaller number. Now, instead of 0.95, I'm going to live a little dangerously. I'm going to make it 0.97. So it's going to be just a little bit thinner. It is going to be just a little bit thinner than the than half. Yeah, half would be 0.5, and it's going to be a little bit less than that because I'm multiplying it by 0.97. And I'll say okay. Oh, thickness times 0.97. Okay, so that's the outside radius. That is the outside lip radius. What is the outside lip? This is the outside lip, and it is the radius out to here. Okay, so now I will come back over here, and what I need to do this time is I need to add another parameter, and that parameter is going to be the inside lip IL radius. And then what is that going to be? Well, it's going to be very similar to the other one, but it is going to be the inside radius, the overall inside radius, but this time it is going to be plus 0.5 times the thickness times 0.97. Okay, so the inside lip radius, I'm going to start with the inside radius, and then I'm going to add half the thickness, but I'm not going to quite add half the thickness, a little bit less than that. So I've got 3% extra space on one lip, 3% extra space on the other lip. Hopefully with that two combined, they should work. All right, so I think that I pretty much have my parameters done now, and most of the work is creating a good set of parameters. So now what I'll do is I will come in and I will create a sketch. I'm going to sketch in the XY plane, and then what I'm going to do is I'm going to start by drawing a big circle, and that big circle is just going to go out to outside radius like that, and I'm going to say okay, outside radius, and let's get that out of the way. Okay, now I'm just going to flat out do an inside radius. All right, and so I'm going to come here, and this is going to be the full inside radius. Enter, enter. And so if I didn't have to worry about the lips, I could just extrude this thing around and we would be done. But what I'm going to do is this one is going to be this one that has the outside lip. I'm going to put the outside lip down because I think it'll be a little bit easier to print there. So here now I need to do the outside lip radius. Okay, so there is a magic third circle, and that is going to define the outside lip radius, because that is the outside lip. All right, does that look good? Enter. And let's move these things out of the way just because I don't like them messing up my drawing. Let's get that like that, keep things neat. Okay, that looks good. Now, I think I'm ready to go ahead and finish that sketch. So I'm going to finish it. I'm going to come here like this. Now what I need to do is I need to create the path. So I'm going to create another sketch. This one needs to be orthogonal to this. So again, I'm going to use the red-blue plane, which is the XZ plane. And now I'm going to draw the path that I will extrude that along. So I think the best way to do it, I'm just going to start with a rectangle, and that rectangle is going to be span L in this direction. That's how far it goes this way. And then how far up does it go? Span height, like that. And then enter, enter. All right, so I'm beginning to get my path put together, but you wouldn't want to come up here and try to do a sharp 90-degree curve. That wouldn't work very well. We want to gently go around that corner. So who is our friend? Mr. Fillet is our friend, and I want to fillet this to this. Just whatever it pops up. For the radius, no. What did we say this was going to be? This was going to be curve. It was that parameter. And then you can see when I do that, I've created a much more gentle path for this circle to flow around to create a nice elbow. Okay, now what I need to do is I need to trim this thing up. And so I'm going to get my trim tool. I'm going to take that off, and I'm going to take that off. And then one of the problems that you can see is that I lost that dimension. And so because I lost that dimension, I couldn't come in and I couldn't change this length along here. I couldn't change span length. And so even though when that parameter disappeared, when I clipped this bottom this bottom segment, I think the dimension was tied to the bottom segment. So when I lost the bottom segment, I lost that constraint. So I'm just going to go in and I'm going to say put a dimension. So I'm going to put D. Put a dimension from here, this point, over to this point. And the good news is it put in 60, which is what we set span length to, but I don't want it to be 60, I want it to be what? Span L, like that. Okay, now it's 60, but it's not the number 60, it's the parameter for span L, and that number that goes with that parameter is 60. And look at that, boom, over here we are fully constrained. So guys, the moment of truth is coming here. So we're going to come here, and the first thing that I'm going to do is I'm going to create the whole body. And so when I create my sweep, I'm going to extrude everything. Okay, so I'm going to get this, and I'm going to get this. I'll come back and I'll cut those lips because I've got the guideline to cut the lip, but I'm just going to go all the way around. And then what path? That is my path. And then I don't have a guide surface. And why is this thing not happy? Oh, I don't want path with guide surface here. That's what it was set to last time. I want single path, and boom. So you see, I've got an elbow. It looks a lot like this elbow. It is very nice, very good. I'm very happy. But what do I have to do now? I need to go in and put these cuts. Okay, and so I'm going to come down here. I'm going to turn that first sketch on, and this one is going to be the outside lip. So if this one is going to be the segment with the outside lip, I need to cut out what? I need to cut out the inside. So I'm going to do a extrude, and then I'm going to extrude the inside, and this is going to be a cut, right? So I'm going to come down and I'm going to say cut, and then how far do I want to go? I want to go by the overlap. Did I put that in? No, I didn't put that in. Let's see if I can add it here. Change parameters. I forgot to put in overlap. Overlap. And I'm going to put in an overlap of 20 millimeters. Okay. And so now if I come and select this, I'm going to say extrude that. Okay. And I want it to be a cut, and I want it to go by overlap like that, and then I'm going to say okay, and boom, look at that. Okay, look at that. So I have my outside lip, the inside part was cut, and this wall thickness here is a little less than half of the overall wall thickness. It's half of the overall wall thickness times 0.97, if that makes sense. Okay, that is really neat, but we still have to come up here and do this. And you see we don't have anything to work with here, so we need to make our circle. So what I got to do is I got to create a new sketch. Okay, I'm going to create it on this surface. Now I'm going to create a circle. I got to make sure that I snap to that center point, snap to it. Now I come out by what? What am I making here? Am I making the outside lip? No, I'm making the inside lip. So this is the ILR for the inside lip radius. And then I click enter, and then I click enter, and there it is. And now you have to ask yourself, what am I going to cut this time? What am I going to cut this time? This time I'm going to cut the outside, and that will leave me with the inside. And so I will come here. I need to finish my sketch. I'm going to come here, and I am going to extrude. And then how far am I going to extrude? I'm going to extrude by overlap again. And then this time it is going to be a cut again. And it's not happy this time. Why? It's trying to come out instead of go in. And you never really know which direction it's going to go, but what I can just come in is just come in and say go the minus of that. And then let's see, yeah, it's going to like that. And okay, boom. Look at that. Now I have got my elbow defined in a parameterized model. So let's come in and play with this. So let's say modify our parameters. And in the overlap, what if we made the overlap 5 instead of 20? You see, now I've got just a little bit. That would be freakishly small. What if we did 10? Okay, we could do 15 like that. That looks pretty good. 15 looks pretty good. Also, remember, we could expand out. We could expand that out. And so the length, instead of 60 millimeters, what if we made it 120 like that? And then we still have the lip. That lip would still fit here. And just remember, we do have that cutout spot in there for things to plug into. We could also make it a tighter corner by changing the curvature. No, the curvature sticks with the outside radius. That kind of makes sense. Let's see what else we could play with here. Let's play with the thickness. Instead of a thickness of 4, what if we made the thickness 15? And then you can see we got a heavy duty pipe, but still these things, I think it would be helpful to turn the sketches off. Still, these things would plug into each other. So you see, I'm doing a lot of monkeying around with these parameters and changing my design. But yet this thing would continue to work. So you see, you just got a very useful tool here. Now, you've got a very useful model here. What I would like to do is I would like to make parameterized models for other things like a straight segment and then like a T segment, and the other things may be a Y where you come in and you Y out from 1 to 2, and then just be able to go in and sort of design an arbitrary piping system using these models that I have in Fusion 360 and then printing them. And so how cool is that? Guys, I hope you're having fun with this. Now the real question is this thing going to print? And why did I have you print that? Because if you make this wall thickness 4 millimeters, so let's go back and do that again. So let's come back here and say change parameters, and let's make the wall thickness. Where is that wall thickness? That was 4, like that. And then I'm also just going to change these back to what I had them 60, and then this was 60 like that. And I think that's pretty close to what our original model was. Now, when we print this thing, what I want you to see is that this ring that is sitting on the build plate is just 2 millimeters thick. Now, that is a real challenge to print because it's a very, very small area of adhesion. And if things aren't perfect, this is going to fail and pop off before the thing finished printing. But remember, a couple of lessons ago, I told you my techniques for getting perfect prints every time, where my prints, even challenging ones like this, will stick. And also, now you would have to decide here for yourself how you would want to print this. Like, you might think, I would like to print it laying down on its side, or I would like to print it like this with that one down, or print it like this with that one down. Or maybe you would have some crazy idea that if you put it like at a 45-degree angle and maybe gave it a little bit of a raft and a little bit of supports. There's all types of different things that you could think of in trying to print it. I just wanted to try to print it without any supports and without any rafts. And it is underway. My print is underway here. Let's see if I can switch over to that camera. I probably am going to have to adjust it a little bit there. Let's see. Okay, you can kind of see that. Let's see if I can zoom in a little bit. And I will need to... A more professional operation would have had this stuff set up already ahead of time, but we go a little bit rinky-dink here sometimes. Okay, and then let's see if we can come in a little bit. That's not too bad. Guys, this is pretty amazing. You can see that we are really getting pretty far along on this print. We are getting pretty far along on this print, and it is still adhered. Now, if you look, this was a very sharp corner, and when you were making the first few passes here, it's like you were trying to print over air. So you can see I've got a little bit of filament hanging down, but I think I could clean that up. And then what I'm going to be really interested in is seeing with those tolerances that I did, if those things are going to plug into each other and make a proper joint. And so maybe what I'll do is I'll just pause here, and then we'll come back in a minute when this thing finishes printing. Okay, so you guys just have a sip of coffee, and I will be right back. Okay guys, we are getting really close here to having a successful print, and what I am really delighted with is notice that these things have gone through the entire print and are still firmly affixed to the bed. And it is a 2mm ring. The wall thickness of the contact area with the build plate is 2mm, and so that is actually absolutely amazing adhesion. How did we get it? Because we always make sure that we have a fresh nozzle. We leveled the bed before we started, and then we did a bed mesh. Cleaning the bed, having a good nozzle, leveling the bed, and using a bed mesh, and just a few little things like that, and we can get perfect prints every time. Now you can see this is almost done, but the real problem area in trying to do this print was in this area where it was trying to print over air. And so you can see I got a few filaments there. I do still have structural integrity on this lip. So what I hope to do is in about a minute, when that thing's done, I'm just going to clean it up a little bit with these clippers, and then we're going to see if the tolerances that we used were correct. We might need to put a little bit more tolerance because we've got a little bit of a jagged edge down here. But I hope you guys see why I printed it this way. The inside part here, which would be hard to clean and clip, is printed in the right direction, so I won't have to clean up in there. And then the area that I knew would be hard to print and the area that would have the problem would be on the outside, where at least it will be easily accessible to hopefully come in and get that clipped off a little bit. But I think we are done. All right, guys, look at that. Look at that. And so we will try to make use of our iPhone 14 here to perfect use of the iPhone. Okay, now I'm going to look at these two, and what I'm going to try to do is I'm going to try to clean this one up here. And so can you see that? I think if I just came back up here full size, that would probably work the best. And so let's just come in and let's see if we can clip off some of this nonsense here. And I'm not going to waste a lot of your time if this doesn't just come right off, but I want to see if I kind of have something that's close to fitting. I want to see if I have something that's close to fitting, but really, this just looks super clean. This is looking really good. And just where it was trying to do that absolute horizontal print over air, we had a little bit of a problem. How can I show it to you here? Okay, that looks good. And then we'll come over here, and I got a little bit of mess in there that I'll try to get out of the way. What the mess inside is, it's where that edge of the lip is. It's vertical. I should have put a little taper on there, and that would have gone a little better. But boom, look at that. We have two elbows that kind of very nicely fit together. They're snug. I think probably what I would do is these are very nicely, almost perfectly snug. But if I were to do this again, I would probably reduce my tolerances a little bit more, make them a little bit tighter, and then I would clean this up a little bit more. But boom, we have got that. After I finish with the video, I will come in and clean this other one up. And then I'm probably going to print a variety of these things and see if I can make some neat little gizmo using a little bit of library of these different pipes and connectors. Guys, I hope you're having as much fun taking these lessons as I am making them. I am really enjoying how we're advancing our design skills and then advancing our print skills, advancing our design skills, and advancing our print skills. Leave me feedback down below. Were any of you guys able to go in and design this and print it and get it to work? Give me some feedback. Hopefully some of you guys have posted your homework solutions, and also continue to give me ideas on what you would like to see in future videos. Okay guys, if you liked the video, be sure to give us a thumbs up, subscribe to the channel, and make sure that you share this with other people, because the world needs more people doing engineering and fewer people sitting around watching silly cat videos. Paul McWhorter with TopTechBoy.com. I will talk to you guys later.